to summarize Tableau 8, Part 2, Additivity and the Theorem of Total Probability. In the simplest setting, additivity in conditional probability manifests itself as a chain, and you can break up a target event H based upon a partition based on side information, either in event A or its complement. This turns out to be an extraordinarily profitable way of thinking about breaking up a problem. Total probability is an extension of this additive idea to partitions involving more than two elements, to a partition involving a finite number or possibly even a countably infinite number of events, and in which case we now have a chain formulation for the probability of a target event H in terms of conditional probabilities given various input events, if you like, Aj. A corollary to this theme was our ability now, once we have this formulation of total probability, of reversing the direction of conditioning, figuring out a posteriori probabilities after the fact via Bayes' rule. As I mentioned earlier, a beginning student should probably not try to memorize Bayes' rule in itself, but understand how it arises by a systematic application of the idea of total probability of additivity. This concludes our discussion of conditional probability for the time being. Our next lecture, Tableau 9, will deal with perhaps the fundamental aspect of the theory of chance, which rescues it from being merely a fragrant bywater of a general abstract theory of measure. And the concept, the idea I'm referring to, is the understanding of the idea of statistical independence. This will then be our focus on Tableau 9.